So today we have a nice integration question. It has been asked to find the integral of 1 upon sine square x into cos square x. Now I actually have two ways to solve this particular question, and in this video we are going to see both of them. Now let us start the solution by taking this integration as equals to I. Now let us see the method number 1. So in the first method, what we are going to do is multiply 4 in the numerator and in the denominator. Therefore, I would be equals to integration 4 divided by 4 times sine square x into cos square x dx. Now we can simply take the 4 in the numerator outside this integration. Now the integration sign 1 upon. Now 4 times sine square x into cos square x can be written as 2 times sine x into cos x the complete square dx, and this thing is equals to I. Now look carefully at the denominator part. It is 2 times sin x into cos x, and it resembles the identity of sin 2x. Therefore, the integration I would be equals to 4 times the integration 1 upon sin 2x the complete square and dx. This thing was actually the identity for sin 2x. So here we have a value of I, that is 4 times integration of 1 upon sin 2x the complete square. Now this thing can also be written as cos x square 2x. Therefore I would be equals to 4 times integration of cos x square 2x dx. Now a simple substitution rule would be used because here 2x is there. So we'll simply take 2s as equals to u. Now we'll take derivative on both of the side with respect to x. Therefore, derivative of u with respect to x equals to derivative of 2x with respect to x, that is equals to 2. So from here the value of dx is going to be equals to du upon 2. Now in this equation, the value of dx would be replaced with this value and 2x would be replaced with u. Therefore, the integration I would be equals to 4 times integration of cos x square u du upon 2. Now from the table of 2 it goes to. Therefore, this thing would be equals to 2 times the integration of cos x square u du. Now remember the integration of cos x square u, and it is going to be equals to negative cot u. Therefore, here we have the value of I as equals to 2 times negative cot u plus the constant c. Now remember that we have taken u as equals to sin 2x. Therefore, we finally have the value of I as equals to negative 2 times cot 2x and plus the constant c. So here we have got the value of I, that was the integration of 1 upon sin square x into cos square x with respect to x. This was equals to I, and here we have got the value of I, hence we have got the value for this particular integration. So this was the method number 1 to solve this particular integration. Now let us see the method number 2. So here we have a second method to solve the same integration question. So here we have the value of I as equals to integration of 1 upon sin square x into cos square x dx. Now in the numerator we can see 1. Now remember the trigonometric identity, or I should say the universal trigonometric identity, or the most famous trigonometric identity, that is sin square x plus cos square x as equals to 1. So we can simply replace the 1 in the numerator with this particular value, because this thing is equals to 1 upon sin square x into cos square x as it is and dx. Now we can separate the denominator over here. Therefore, integration of sin square x upon sin square x into cos square x plus cos square x divided by sin square x into cos square x dx. Now we can see that sin square x got cancelled out, and over here cos square x and cos square x got cancelled out. So what we finally have as the value of I is equals to integration of 1 upon cos square x plus 1 upon sin square x dx. Now this thing is ultimately sec square x, and this thing over here is ultimately cos x square x. So integration of this thing is equals to I. And this type of situation we can just separate this integration sign. Therefore, I would be equals to integration of sec square x dx plus integration of cos x square x dx. Now remember that integration of sec square x is equals to tan x, and integration of cos x square x is negative cos x. Therefore, plus and minus becomes minus cot x and plus the constant c, and this is the value of I. So here we have got the second value of I, that is ultimately the second value for our integration. Now you might be thinking that yes, two methods for the same integration is all okay, But why the answer is different? Because in the first case we got answer as negative 2 times cot 2x, and here we have the answer as 10x minus cot x plus the constant c. Look carefully that these answers are in trigonometric values, so we can just play further with trigonometric values so as to get the final answer. Like here we got the value of I as equals to 10x minus cot x. Let us simplify it further. So over here the 10x can be just written as sin x upon cos x minus the cot x, that is equals to cos x upon sin x. And now over here we take the LCM, so we will have sin square x minus cos square x divided by sin x multiplied with cos x. Now in the numerator we can say sin square x minus cos square x. Now remember the identity for cos 2 theta, that is cos square x minus sin square x. So what if I take negative on both of this side? So on the right hand side we will have sin square x minus cos square x, and on the right hand side we will have negative cos 2x. Therefore the numerator over here can be replaced with negative cos 2x upon sin x into cos x. Now what I will simply do is multiply 2 in the numerator and in the denominator. Now the denominator turned out to be 2 times sin x into cos x, that is ultimately sin 2x, and we have 2 in the numerator, so into 2. So here we have negative 2 cos 2x upon sin 2x is ultimately cot 2x and plus the constant c. So here we can see that for the value of I that we got from our second method is 10x minus cot x plus the constant c is same as negative cot 2x plus the constant c, and this thing we got as the answer because of our first method. So the final answer by the method number 1 and method number 2 were just same. We have to just do a further calculations because they were trigonometric values. But the main thing was that two methods for the same integration question. So if you have got the answer to this as negative cot 2x plus the constant c, you are absolutely correct. And if you have got any other, means any other answer in trigonometric ratios, just try to simplify and see that if it comes as negative 2 times cot 2x or not. If it's not coming, then you might have made some mistake. Okay, so here we have got the answer as negative 2 cot 2x plus the constant c. And I repeat that if you have got any other trigonometric values as answer, try to simplify it further so as to reach this particular thing.